So if you talk about material classification, let us continue from what we had left before. So if you talk about material classification, materials are generally classified under these four heads. So the first one is homogeneous and isotropic. So homogeneous means it has the same chemical composition throughout the material. So this term you must have seen in chemistry. It is related to, so it has same chemical composition throughout. So same chemical composition means if you mix salt and water, so it has the same, it will become a homogeneous solution. And non-homogeneous means if you are mixing sand with water. So if you are mixing sand with water, what happens? It becomes a non-homogeneous, means you have different compositions at different locations. Moreover, if you talk about materials like we have steel, etc., steel, gold, silver, copper, these are all homogeneous materials. So the other option is, these are basically synonyms and antonyms. You have a material and the opposite is mentioned here. Now, isotropic means that it has different material properties. It has different material properties. So, uh, if a material is homogeneous and isotropic, isotropic means it is related to material properties. Okay. So, if you say uh, that a material is homogeneous and isotropic, it means that the material has the same uh, chemical composition and material properties. Now, material properties again means it is mechanical properties. It has the same mechanical properties in all three directions or all three planes, x, y, z plane. So, the opposite of homogeneous is non-homogeneous, and the opposite of an isotropic is anisotropic. So, what is an isotropic material? It has different mechanical properties in different directions. In different directions. Now, let me give you an example of an isotropic material. An isotropic material, the most common example that we see in day-to-day life is ginger, अदरक. ठीक है, अगर आप अदरक को देखें, अगर आप लोग किचन में जाके कभी अपने अदरक को काटा होगा, अदरक अलग अलग एक्सिस पे अलग अलग ताकत से कटता है. If it is cut along the fibers, it is cut very easily. If it is cut across the fibers, it becomes really difficult. Onion, pyaj, if it is cut across the fibers, it is difficult to be cut. If it is cut along the fibers, it is very easy to be cut. Wood. So these are those materials which are anisotropic in nature. That means they have different mechanical properties in different directions. Even the plastics that are manufactured for a specific type of use, they behave differently in different directions. Like you must have seen white polythenes that are used nowadays for carrying daily vegetables, etc., that is available on the shop. The entire load will be acting on the downward side. So the properties along the downward direction are different as compared to the other two planes, because other two planes are not subjected to a huge amount of load. So if you try to subject the other two planes by a huge amount of load, so sideways it is very easy to burst out rather than from the bottom. So you have materials which behave differently in different directions. So homogeneous material means it has the same chemical composition, and isotropic materials means it has the same mechanical properties in all three directions. So the opposite of homogeneous is non-homogeneous, and the opposite of isotropic is anisotropic. So anisotropic means it will be behaving differently in different directions. Now, the second material classification is rigid and linearly plastic. Now, rigid means it will not respond to the stresses, or it will not undergo any change due to the applied load. So, if you say, you must have heard the term rigid body and rigid supports. So, the term rigid means that it is something, if you say a rigid support, it will be able to sustain an infinite amount of reactive force or reaction on it. If you see a rigid body, then in spite of applying any amount of force or load or anything on the body will not undergo any change. And its opposite now is linearly elastic. Now, elastic material is a material which, upon application of load, shall behave in a specific manner and come back to its original shape and size after removal of load. A linearly elastic material means that it is a material which will, this will respond to load. It will respond to load and come back to its, and retrace its original position. Original position will be a different word. Let us say shape and size. Shape and size on a removal of load. So whatever changes it has undergone, it will come back to its original shape and size. A plastic material is a material which undergoes permanent deformation under the application of load. So plastic material means it will undergo permanent deformation. It will undergo permanent deformation on application of load. So this is the definition of a plastic material. And rigid plastic material means a rigid, a rigid body that will undergo no deformation, a rigid body made up of plastic which will undergo no deformation under the applied load. So the definition of rigid remains the same, only plastic has been added here. Now let us come to ductile material. A ductile material is a material which can be drawn into wires. Which can be drawn into wires. So means you can continuously keep on applying tensile load on it, and it can be drawn into wires. So that is called as a ductile material. A brittle material is a material, it will sustain load to an extent and then break into pieces. This is a material which will sustain load to a certain extent and then it will break down into pieces. So that is the example of a brittle material. Okay, so these are four basic material classifications, how we try to understand and how we try to classify or put materials into specific categories. So let us try to understand these 10 mechanical properties. So the first one is elasticity. Elasticity means it is the ability of the material to undergo temporary deformation. It is the ability of the material to undergo temporary deformation, like you have rubber bands, etc. Now plasticity means It is the ability of the material to undergo permanent deformation. See, to undergo permanent deformation. Ductility means it is the ability of the material to be drawn into wires. Malleability means the ability to be beaten down into sheets. Now, toughness, it is the ability to resist fracture. So, resist fracture means if you are applying a certain amount of load on it, how long will it be able to sustain that load without undergoing fracture? Okay. Now, resilience means the ability to absorb energy. Okay, now let us say you have an iron sheet that is used in construction of shock absorbers, and you have an iron sheet which is used to construct a knife. In the case of the knife, the uh, sheet is required to have high toughness because it should not undergo fracture or any type of such deformation while doing or performing cutting action. Now, that same iron sheet with a different chemical composition will be used in shock absorbers. Now, there the property desired is whenever energy is been given to it, it should try to absorb the entire amount of energy and release it slowly, because some iron material is used to create springs also, and that same iron material is used to create knives also, and both as they are performing different operations, so they need to behave differently. Okay, so stiffness is the ability to resist deformation under stresses. So stiffness is the ability to resist deformation under stresses. Now, stiffness means if you have a beam and let us say you have some member and you are trying to bend it. If it does not bend easily, or if you have two materials under the application of same load, the one which bends lesser is said to be more stiff. Stiff का मतलब अकड़. तो अकड़ उसमें ज़्यादा है, which is undergoing the least amount of deformation under an applied load. Now, hardness is the ability of the material to resist indentation. Indentation. Now, indentation is also called as scratches. Okay. So, शीशा जो है बहुत हार्ड है, तो मिरर, ठीक है, आप लोहे पे भी अगर नाखून से खींचोगे तो एक दाग बन जाता है, शीशे पे अगर खींचोगे तो दाग नहीं बन रहा, ठीक. So hardness is the ability of the material to resist indentation or scratches. Means under the influence of the load, there should not be any permanent scratches or indentations being produced. So if you have two materials under the same load, if they produce scratches of different shape and size, that means जिसमें scratch कम आया, that is so assumed to be more hard. Now creep, this is a failure when material is loaded for a large time. This is a time based. Now, आपने देखा होगा कि एक जगह मान लीजिए आपने एक पत्थर रख दिया, पत्थर का वजन बहुत कम है एज कंपेयर टू द लोकेशन वेर यू हैव केप्ट इट. बहुत टाइम तक रखे रहने के बाद जब आपने पत्थर हटाया तो देखा वहां पे थोड़ी सी जमीन धस गई थी या सामान धस गया था या परमानेंटली वो कुछ इसमें डिफॉर्मेशन हुआ, तो दैट टाइप ऑफ डिफॉर्मेशन इज कॉल्ड as creep when the failure takes place in the material when it is loaded not by a very huge amount but for a large amount of time. So that is creep. And this fatigue is failure when the material is loaded for repetitive cycles or repetitive cycles. So repetitive cycles means you have fluctuating stresses, sometimes compressive, sometimes tensile, which are being continuously been applied over a time. Either they can follow a pattern or they are found following any random pattern, and the load is substantially less than the failure load. And if this goes on happening for a repetitive number of cycles, the material undergoes fatigue failure. Now, what we have, these are all about material properties. Now, what we have learned from Hooke's law is delta L is given by PL by AE. So now what happens that let us say that we have a rectangular bar. So and it has been subjected to some tensile load P. So this will not be represented as 2P. Why? Because this is either of them is a reaction. Because if it does not happen, the material will start moving in one direction. So whenever you are applying a push or a pull on a body, that has to be understood with the help of a statement. And now the statement what it says is force means a push or a pull. So what you have learnt is this is a vector quantity, and a vector quantity has magnitude and direction. A vector quantity has a magnitude and direction. A scalar quantity is a quantity which has magnitude alone. Now this is the definition as suggested by physics. Now engineering says that this is one third term sense. It has to have a sense. Now sense makes you understand the effect of application of load. Now, effect of application of load, let me try to explain you with a small example. If this is the designation, first condition, body moves. So, no stress. Second is body still is still. Then friction is taking all of the load. Okay. Third, body is still. Stresses are produced. So if stresses are produced, that means a reaction has been offered. And that reaction will be in the opposite direction. So this will make you understand. Now these three, four statements, they correspond to sense. So magnitude and direction is the physical definition of a vector. Whereas if you talk in engineering terms, you have to understand sense. This sense is actually cause effect analysis. Now, cause effect analysis says that if cause and effect do not exist in the same equation, that equation is not an engineering equation which can be used for any mathematical application. The cause and the effect both have to exist in the same equation. Okay, so delta L now becomes equal to PL by AE. Delta L, change in direction, this is your effect, and this P is your cause. So this is how we try to designate things and make you understand.
Excuse me, sir.
Huh.
Sir, what is the difference between body still and
Now, tapered bar means that you have a bar which has a continuously decreasing or increasing diameter over a fixed length. So let us say that this is a bar. So if it is having the same cross-sectional area at every point, then you can apply delta L is equal to PL by AE and calculate whatever is required. But here what is happening is, this is a circular bar in which the dimensions are continuously, if you look from this end, the dimensions are, or the radius or the diameter is continuously decreasing. If you look from this end, then the radius is continuously increasing. So let us say that this dimension is d2 and this is dimension d1. If the major diameter is d1, if the minor diameter, the smallest diameter is d2. If d2 becomes equal to 0, this becomes a cone. Okay, and this has a length of L. So you need to find out the delta L for these type of structures. So what you are doing is, let us at a distance x, at a distance x from here, let us take an element of thickness dx. At a distance x from here, let us take an element having a thickness dx here. Okay. So what you need to find out is delta L is given by PL by AE. So what we are doing is we need to calculate this. So here, if you have a length of the element as dx, that means what you are getting, length is dx. Now, the diameter is d1 here, the diameter is d2 here. So there is some instantaneous diameter here. So now let us find out instantaneous diameter dia at x distance from d1. So if you find out the at if at x is equal to 0, diameter is d1. At x is equal to L, diameter is d2. So at x is equal to x, what is the diameter? So the diameter is given by, let us say we are denoting it by d. This is equal to d1 minus d2 by L into x. So how did you arrive at this equation? Now the understanding is, how did you arrive at this equation? This is done by interpolation. This is done by interpolation. So when you are moving from here, what is actually happening is, with every passage of distance, the diameter is reducing. It is obviously reducing by a uniform amount. So the diameter will always be less than d1, so it is d1 minus. What is the rate of reduction? The rate of reduction is, maximum is d1, minimum is d2, and this reduction has taken place over a distance of L. So the rate of reduction is d1 minus d2 divided by L. This is the rate of reduction. So when you are traveling a distance of x meters, what is the reduction? So this much will be the reduction. So d1 में से इतना घट जाएगा तो आपका instantaneous diameter आएगा. If you put x is equal to L, it should come out to be d2. If you put here x is equal to L, it will come out to be d2. L cancel हो जाएगा, d1 यहाँ से कट गया, d2 बच गया. If you put x is equal to 0, it will remain as d1. Okay, so this is your final equation. Now suppose अगर आपने यही इक्वेशन यहाँ से सॉल्व की होती तो आपका ये डिस्टेंस x होता. इफ यू ट्राई टू सॉल्व इट फ्रॉम दिस डायरेक्शन, तो इक्वेशन क्या होती? तो d होता d1 प्लस, हर बढ़ती दूरी के साथ आपका डायमीटर बढ़ रहा है. सो ये d1 सॉरी d2 प्लस d1 माइनस d2 पर यूनिट डिस्टेंस कितना बढ़ रहा है, दिस इज द रेट ऑफ इंक्रीज, एंड दिस यू आर डूइंग अगेन विद द हेल्प ऑफ इंटरपोलेशन. सो आपको ये देखना है कि आप घटती हुई दूरी की तरफ से ले रहे हो या बढ़ती हुई दूरी की तरफ से. तो आप दोनों में से कोई भी इक्वेशन कंसिडर करो, इट विल मेक नो डिफरेंस. Okay, first let me explain, then we'll be coming on with question answer. Now, as let us, what we are doing, let d1 minus d2 divided by L be denoted by K. So we'll be using this equation. So d instantaneous is equal to d1 minus kx. Okay. So now P is applied load, length of the member is dx, area of the member is pi by 4 d1 minus kx होल स्क्वायर. ठीक है, ये इंस्टेंटेनियस डायमीटर है, तो पाई बाई 4 डी स्क्वायर इज योर एरिया, एंड ई इज यंग्स मॉडुलस. So delta L is equal to P dx divided by pi by 4 d1 minus kx whole square into E. Let us integrate it, and the limits of integration are 0 to L. ठीक है, so if you integrate it, delta L becomes equal to P L by pi E d1 d2. This is 4 PL by pi E d1 d2. So this is your uh, derivation for extension of a tapered bar. Now, now what we have done is we have derived this equation, delta L is equal to 4 PL by pi E d1 d2. This is the extension of a tapered rod. Now let us assume that this was not tapered. So if this was not tapered, then let us say that it has the same diameter. If it is not tapered, that automatically means that d1 is equal to d2. If not tapered, d1 is equal to d2. Let us say this is equal to d. So if you put d1 is equal to d2, so what will you get? Delta L is equal to 4PL by pi d square. For a circular section, this is true, क्योंकि सर्कुलर सेक्शन के लिए डेल्टा एल क्या होता है? पी एल बाई ए इज पाई बाई 4 डी स्क्वायर इंटू ई. ये 4 ऊपर चला गया, तो इसका मतलब this equation is valid for a circular section also. For a circular section, d1 becomes equal to d2, so they can be interchangeably managed here, and this formula becomes same for a circular cross section as well. So for a circular cross section, it is 4PL by pi E d square. If it is a tapered section, then the d is being represented as d1 d2. Why it is represented? This is the justification or derivation of the same. Now this is parts in series. So this is about bars in series. In bars in series, what is actually happening is you have 3 different bars of different shape, size, different dimensions being attached together in series, and they have been applied by a single load P. So if you have a situation like this, then delta L here is given by delta L of 1 plus delta L of 2 plus delta L of 3. So you need to find out the delta L, the change in length that has taken place in body number 1, the change in length that has taken place in body number 2 and 3. So here force remains same, remains same for all sections. So all sections are subjected to the same force. So what happens is delta L here becomes equal to P into, let us say body 1 has length L1, the body 1 has a different area A1, and let us say it is made up of a different material also. So it is E1 plus P into L2 by A2. Now E is a material property. So as the material changes, the value of Young's modulus will also change. And similarly, you can write on PL3 by A3 E3. So delta L, the force will remain same for all the three sections, and you are calculating the total change in length. So obviously this is a single equation, and in single one equation you have to be given all other data and you can find out only one unknown. Similarly, if you look at this problem, this is a constant shape section, this is a tapered section, and this is again a constant section. So here again delta L will be equal to delta L of 1 plus delta L of 2 plus delta L of 3. So delta L of 1 is PL by PL1 by A1 E1 plus delta L of 2 is 4PL2 divided by A2 E2. So A2 will not be mentioned here like this. So this is pi E D1 D2 plus this is PL3 by A3 E3. So what is D1 D2 here? This diameter will be called as D1, this will be called as D2. So if you look at this entire structure, this area becomes pi by 4 D1 square. This A3 becomes pi by 4 D2 square. Okay. And you can put down all other values and calculate the value of delta L.